Hi, I'm Mike McCarthy, and welcome to Talks with Testmeter, a new series helping make sense of all things test and measurement. Today, we're discussing thermal imaging, and more specifically, if you're new to the technology, why you should care about it. Joining me as co-host today is Business Development Manager Chris Fox. As a thermography-trained former electrician, Chris is the ideal man to help shed some light on today's subject. Alongside Chris, I'm delighted to be joined today by Jason Cargill, Technical Sales Specialist from FLIR. As the market leaders and long-term innovators of technology, FLIR are a global brand at the forefront of thermal imaging. Jason will be a familiar face to many in the industry, having trained customers across the UK and to help them get the most out of their cameras. Hello, Jason, and welcome. Thanks for joining us today.
Well, thanks for the invite. Good to be here.
So let's just start from the top, really. What is thermal imaging? How would you describe it to someone who's not aware of the technology?
I mean, essentially everything around us. So, for example, in this room, everything's emitting infrared energy. So thermal cameras allow you to visualize that infrared energy. So it creates what's called a thermogram on a camera, and it allocates colors to the different temperatures. So it's a very visual tool that allows you to effectively see heat. So it's a bit like having a superpower, because you can see what's invisible. So thermography is a really powerful tool, particularly for example, maintenance applications.
Well, I mean, I was saying to Chris beforehand, if you've ever seen Cops, the American TV show with the helicopters chasing the perps, you always see the FLIR footage from that of the guy, the little dot running away. So it has applications sort of from a wider use than just test and measurement, but of course it's hugely useful there.
Yeah, I mean, everyone's seen Predator, right? So obviously in the jungle, Predator's got the ability to see these marines in literally day-glow colours. So that would be my visual representation of thermal imaging, thermography specifically.
Yeah, I mean, you've already sort of talked, Jason, about how it works. It's a technology that sounds quite complicated, but from a user point of view, is actually quite simple, isn't it?
Yeah, I think at FLIR we've designed cameras and solutions which are easy to use. And, it's point and shoot, and that's kind of the power of thermography is that it is so easy to carry out. Now, obviously, knowledge is power. So understanding more about thermography. So, for example, training, you get levels 1, 2, and 3 training, for example, but that adds to the experience of using a camera, allows you to maximize the use of it. But as a subject itself, it's the applications are so diverse. So if someone's thinking about a thermal imaging camera, or even using a thermal imaging camera now, the simple fact is the amount of applications you can use it for are so diverse that kind of you really do get your value for money with thermography.
Yeah, I mean, I was going to move on to that. Who do you think could use thermal imaging, and how?
Well, I kind of from the area of FLIR that I work within, most of our equipment is used for industrial purposes, particularly maintenance type applications. So, for example, electrical, mechanical, process manufacturing industries, electrical utilities, petrochemical industries, paper mills, cement manufacturers, flour manufacturers. There's so many different types of industry that we can use this technology for.
So, obviously, we deal with all range of thermal imaging cameras, but one of the big industries that we see looking into it is electrical, as you've mentioned. So, I mean, how might an electrician use a thermal imaging camera?
I mean, for example, it's a very quick and easy way to find if there's an anomaly. So a particular problem, let's just say, for example, we have a contactor has cables in and out. The camera would see very easily and very quickly if, for example, one terminal was hotter than the others. And if that terminal was hot and part of the cable was hot, the assumption would be that it's a loose connection. If the whole cable was the same colour, as in hotter than everything else, that would indicate an imbalance within the load. So from an electrical perspective, it's things like loose connections, overloads, and other potential problems that can occur within the general decline of assets. I mean, every asset that's installed, over time it will decline. And this thermography is one of the tools we use to establish if there's a problem and trying to rectify that problem. So there's the amount of electrical applications is pretty wide and diverse. Motors is another one, for example. You can look at hotspots on motors and things like that. So
I guess you could use these. Sorry to interrupt, Mike.
No.
For example, with motors, if you've got bearings on these machineries, that perhaps wearing out over time, you're going to be able to see that with a thermal imaging camera purely because those bearings are going to be overheating.
Yeah. You also have, for example, wiring problems within. So within the case of a motor, you can have winding issues where you start to get a breakdown of insulation. So that starts to emit more infrared energy. Then that conducts itself through the case of the motor and shows itself on the surface as a hotspot. And, motors which run above their operating conditions and have problems with insulation, they don't last as long as the lifespan of the motor. So it becomes a very costly issue for anyone who's operating a lot of motors on a site, for example. So thermography is an easy way to monitor motors in operation and under operating conditions.
Sure. I guess even these, like in the electrical industry, when we're talking about, it's such a big industry, isn't it? You've got obviously the one-man bands that are obviously self-employed. You've got multi-electrical firms. I think it's important to note that these devices on the table, I don't know if you can see them on the podcast, but they are very accessible to even just like a one-man band now.
Yes.
I think sometimes the misconception with thermal imaging cameras is automatically you're looking at a device that's going to be costing thousands of pounds, whereas now that's not the case.
No.
So they're accessible to everybody.
Yeah, I mean, we've kind of, our portfolio of products. We launched a product a few years ago called the FLIR 1, which is people are listening to watching the podcast might already own a FLIR 1, but that was a small thermal imaging camera that could be plugged into a phone, be it an Android or an Apple phone. Yeah. We've recently introduced a new version which is compatible with either platform. So you're no longer restricted to a type of connection, so a Lightning or a USB-C. Now you just connect by Bluetooth. So the FLIR 1 Edge and Edge Pro are the latest kind of mobile technologies that we have. And, they're in the regions of hundreds of pounds. So certainly someone can invest in a really good thermal imaging camera, which is useful for many applications, certainly electrical and mechanical in particular, for a relatively low investment, but as a solution which they may find useful for their daily activities.
Yeah, and I mean, just looping back, I mean, that it's all about A, saving money, and B, saving time. It's about efficiency. So that then carries across into other areas as well. So, we've talked a bit about mechanical, we've talked a bit about electrical, but there's things like plumbing and heating engineers. So they can use this technology similarly to save money and time.
Yeah, I'll give you an example. There was a company that manufactured boiler systems, and they used thermal imaging technology to offer a power flushing service for people's radiators. So before they installed an expensive new boiler, they offered this service at a cost to the customer to show the condition of their radiators beforehand, and therefore showing them that if your radiators aren't operating efficiently, you're spending all this money on this new boiler, but your radiators are, blocked 40% with sediment. So they then used that technology to sell another service within their armory, really. So it's also proof of work. I mean, that's another use for thermal imaging as well. You can show before and after images to show that you've repaired a problem or fixed a problem. And, a picture or a thermal image speaks louder than 1,000 words.
Yeah, absolutely.
So obviously we've also discussed previously other applications for plumbing, like underfloor heating. Yeah,
so one of the applications that we discussed earlier on was the underfloor heating leaks. And this is one thing that customers call us very often for. And Jason, you'll be aware that the cameras are very handy in helping to detect those.
Yeah, they are. I mean, it's with underfloor heating, there's no better technology to find leaks quickly. And the best kind of method of doing that is you would turn your system off. You would open all the windows if you can to get the surface of the floor as cold as possible. Then you start your system up, and you can literally trace as the system starts to fill and heat up. You'll have a nice clear line of the pipework, and then at one point you'll have a little bloom of colour, which is essentially is where the leak is. So you can identify that leak under a tile, under a small tile even. Whereas otherwise you might have to use acoustic technologies, and then you might have to start digging floors up. So certainly underfloor heating is a fantastic application for thermal imaging.
Just going into renewables as well, obviously in that plumbing and heating sector, talking about heat pumps.
Yeah.
One of the requirements obviously to be able to test the flow and return in a heat pump.
Yeah.
So again, rather than a contact temperature, a thermal imager could be perfect for that too.
Yeah.
And I mean, we haven't yet talked about surveying and sort of whether that's building or site surveying, really, it has uses there as well, doesn't it?
Yeah, well, if you think about a building, we call it the building envelope. So the envelope's essentially all the windows and the doors. And they're going to be where you get your weak spots. So your door seals mightn't be performing properly. The windows mightn't have been installed properly. You can then have missing insulation. So the insulation, you can use a camera to see from the outside, you're looking at heat escaping out. So for example, you can have cavity wall insulation fitted, or installed, and sometimes it settles in the lower kind of portion of the house, and you end up with none in the upper portion. So you'd be able to see how efficient your cavity wall insulation was. But you can look for missing insulation in your ceiling, or I've used it around my own house.
Same. I was going to say the exact same thing. I've loaned one from the office and I've taken it home and had as somebody who isn't thermography trained even, I've had a play about with it and discovered, that's where all the heat's going.
Yeah.
And it just gives you the opportunity to rectify those problems without having to sort of investigate it too far.
Yeah, we talked about thermal imaging before. What is it? I mean, the thing about thermal cameras, it's a fantastic piece of technology, fantastic solution, but it does rely on conditions.
Yeah.
And what cameras look for is thermal contrast. So they're looking for, the camera's looking at temperature differentials. Now, if we have a motor that's overheating, going back to the electrical application, or a fuse which is about to fail, the temperature differentials are quite high. So the camera gets a nice clear image. Buildings is a bit more nuanced because the temperatures are a lot lower. So we talk about infiltration of cold air into a building or exfiltration of warm air out, but the levels are much lower than you would find with an industrial application. But it's still the ability to see those differences. And as I say, whether it's a underfloor heating system, a door seal, a windows have been fitted incorrectly, and they're letting cold air in. But you also need that. Then you need that temperature differential. So you'd need at least 10 degrees Celsius of difference between inside and outside temperature when you do a building survey, for example. More would be better.
Yeah,
because that will really highlight those issues. But as a technology, like you've already said, it is easy to use because it is visual and it's it's there and it's instant and it's non-destructive. And it's non-contact. So literally, you can use your thermal camera in any kind of environment as long as it's safe for you to do so, without fear of any sort of safety issues as well.
Just very quickly in terms of application, it does have use within, ecology and veterinary areas. Have you got any sort of information about that or examples?
I mean, equestrian thermography is a big application in the kind of the world of animals. I've never done any training with equestrian. I have taken thermal images of friends' horses, not knowing what I was doing. Also, the type of camera you use can become important because you have cameras where you can rotate the lens, which means you can keep your head out of harm's way.
Yeah.
Whereas if you use a pistol grip type camera, you've got to be down there where the hooves are. Now, I was using a pistol grip camera, so, thankfully I didn't get a kick in the head.
I was going to say, that's what happened then.
It would explain a lot. Yeah, but so we've talked about a number of applications. Something we didn't mention was water leak detection. So essentially, when water evaporates, it cools. That's its physical nature.
Yeah.
So when people think about thermography, they tend to think about heat and hot and higher temperatures, but actually thermal imaging can be used for lower temperature applications as well. I mean, the interesting thing is, scientifically, infrared energy starts to be emitted from minus 273 degrees Celsius, which is called 0 kelvins, but that's a temperature we'll never experience.
Hopefully.
Unless we get cryogenically frozen, maybe. But it just shows you that, some of our cameras will go down to minus 25 degrees Celsius.
Yeah.
So water, as it cools, as evaporates, it cools. And it's a really, really great way to identify where leaks are coming from. We could have a leak coming through the ceiling here, dropping on my foot. But if we went into the roof void, we might find out it's tracking from 100 feet away. But you'd see that line very, very clearly. I did a visit to a site that was manufacturing food products. The maintenance engineer wanted a camera for electrical mechanical maintenance. Yeah, great. We proved the technology is great for that. I then opened the conversation up to other things. Because it was a food plant, if you have a water leak at a food plant, you need to address it quickly. because it concerns over Legionnaire's disease and this kind of thing. So that was an application he wasn't aware of, but was also another use for the camera. We also looked at the way that they sealed sachets of coffee powder. You know, you could take an image of a number of coffee sachets, you could see the glue as it cooled. So this is the whole thing we talked about right at the start, about the diverse range of applications. So water leak detection, as in just looking for water leaks, is one of the biggest uses globally for thermal imaging technology as well. So,
wow.
But it is also the other end of refrigeration, HVAC, freezing applications. Yes, that's just another use.
I mean, we've touched upon the difference in price. Can we talk about that a little bit? Obviously, we said people do have these ideas that these instruments are going to be hugely expensive, tens of thousands of pounds. And while there are models out there that are at that sort of price point, there's also ones that are a lot lower.
Yeah, absolutely. So we touched on it briefly earlier on that these devices are now applicable to pretty much everybody. The FLIR one that Jason was talking about earlier on that links up to your smartphone, so you can obviously see the thermal image using your smart device. I mean, these sorts of devices start at £300 and under. So, when you consider a flue gas analyzer, perhaps if you're a plumber, or a multifunction tester if you're an electrician, it's almost half the cost. So, of course, they are accessible. Moving up the range, you can buy a thermal imager, the C3, the C5, which are very similar in design to a smartphone, but they've got the thermal detector built into them. Again, you can pick one of those up for around the £500 mark and under. And then obviously you move on to more of a handheld pistol grip device that Jason was talking about earlier on, and anywhere just under £1,000 really for one of those, which is going to give you a slightly better quality image, and it's slightly more thermally sensitive as well.
I think as well, one of the key considerations is the temperature range that you need the camera to be able to detect up to.
Yeah.
If you have an application which is related to furnaces, for example, it's no good looking at a camera which has a temperature range of 400 degrees Celsius. So for example, we have the TG range, which is kind of the entry-level pistol grip cameras that we have. Within that range, we have a high temperature version, the TG297. So that's a 1,030 degrees Celsius upper temperature, which is useful for kilns and furnaces and those kind of applications. So the temperature range is an important question to ask. What am I going to be looking at for the start? Because that will change what options you do have.
Yeah.
But it also means that you're not spending hours scrolling through different specifications. If okay, well, I needed to detect at least this temperature, then you can narrow down your choice. And the one thing that obviously we have on the test meter site and the FLIR site is a lot of information on there in regards to specifications. But yeah, so through the range, there's different models within each range. And as Chris was saying about the pistol grip format, or the mobile phone type format, which we call compact, and the mobile technologies, there's different choices for different people. And when you talk about the FLIR One Edge, which is the new mobile one which links to your phone, either Apple or Android, that's also compatible with something called FLIR Ignite, which we'll talk about later on, which again is a solution for storing images and using them to create reports. So yeah, there's a lot of options out there, definitely.
I mean, to make life easier when you're buying these thermal imaging cameras, we've done a lot of work recently on the website, our website, which should pop up later on the podcast, where you can actually select these different features. So if for example, like you've just said, that you want a higher temperature range, you can select that, and then it'll return the applicable products for you to make that buying decision a little bit easier. You can narrow it down by application as well. So for example, if you are working in the equine industry, then you could select that, and then it'll return the applicable results there as well. So go and have a look and have a play around and see what you can return.
Yeah,
it can be a bit of a maze for some people to actually navigate when they're coming to look for the right camera, and that's where both companies like FLIR and Testmeter come in to try and bridge that gap and make it easier for customers to find the right instruments.
Yeah, absolutely. I think our details will pop up on the video later on, but obviously we have 2 or 3 guys in our sales department who are level 1 ITC trained. So, we've formally versed in all the knowledge that Jason's talked about today, and we can pass that knowledge on to customers who are interested in buying these devices and obviously advise to them appropriately.
Yeah, I mean, it's one of those things that once people get in their hands, I think they realise that, not to sound like a soundbite, they realise the possibilities.
Yeah.
Because actually you can get it for one thing and then go, oh, hang on, I can spot, I can do predictive maintenance, I can spot leaks, I can spot, issues on the floor. You can use it for a multitude of things.
Well, you just mentioned predictive maintenance, Dan. We never really touched on it in the software side, but we've introduced a facility called Route Creator.
Yeah.
So it's on the premium range camera. So it's at the higher range camera, which we'll talk about another time in more detail. But ultimately, it allows you to essentially build a route for asset management and predictive maintenance. So say, for example, we're in a switch room now, and we have 12 motors to look at. You can build that route on a PC using a desktop. You can build the route that you want to check. So motor 1 first, inspection points 1, 2, and 3. Move to the next motor 2, inspection points 4, 5, and 6. So you build the route into the software. You then load that route onto your SD card from your thermal imaging camera, and then you load that route into the camera. And that uses then the functionality which is called inspection route in the camera. And the camera will then tell the user. So it doesn't have to be anyone who knows about the assets. They just have to follow the instructions on the camera. And it also has a reference image facility. So you can overlay the previous image of that motor. Literally overlay it so you know you're in the same position, at the same angle, the same distance away, so that you're getting that repeatability, because repeatability of thermal images for trending is really important. It's no good being 5 feet away one day and 45 feet away the next time you take an image. You need to try and repeat the same procedures. So our Route Creator and inspection route technology really puts the power into the user's hands to say, okay, we're going into this area now. Start route on the camera. The camera will tell the user what to do. So therefore, it allows people who are maybe not qualified in thermography to be able to gather the data. And then someone who is qualified in thermography can then interpret that data. So again, that's another feature that we've launched in recent times as well. So that's something to bear in mind if you are interested in asset management and predictive maintenance. That's a really good software solution within the FLIR range as well, in conjunction with the cameras.
Well, I mean, it sounds like there's, like I said before, a whole host of applications that can be used, and it's never been easier to get hold of these instruments. That they're obviously on sale at Testmeter, but in terms of the price points, ranging from 300, I think you said, up to 20,000, depending on what you need. It's one of those areas that continues to grow, and the more people that can use that technology, the more they'll reap the benefits.
I think there's a perception, and I've been in the industry a long time, too long to mention really now, but the thing about thermography is, in some cases, people think it'd be nice to have. They don't really see, actually, you really need something like this. You just don't realise you need it yet. But even if you want to put your toe in the water, you don't really understand what thermal imaging can do for you till you actually start to use it and you take the plunge. Now, obviously, you talked about this and the qualifications and the experience that Testmeter has as a FLIR master distributor within the UK. That level of knowledge is important. So if someone's asking a question, they're going to get a qualified answer. Based on experience and based on, obviously, connection with FLIR as a manufacturer as well. Yeah. And obviously, there's a lot of collateral out there which can really help support your decision. Even things like if you look on the FLIR site, we have a return on investment calculators and we have field of view calculators, and these all become more apparent the more that you look at the subject. But all we're all trying to do is help customers choose the best solution for them, and whether it's based on budget or whether it's based on application, or whether it's based on highest temperature range. There's a lot of different factors that you look at. The form factor. Do you want pistol grip? Do you want a rotating lens so that you can sort of keep looking down at the camera while the lens is looking up, which is useful for buildings? Yeah. But definitely never been a better time. The technology is now more affordable than ever. Doesn't mean it's not a big investment in some cases, but it's all, you have to relate it to the potential benefits you're going to get from the additional functionalities and the higher resolution and the better optics. And there's a lot of questions that you can ask.
Yeah, I think having all that information out there is great, but like Jason says, until you get it in your hands, you don't know what avenues that's going to open for you. And it might be that you might want to dabble in that technology first without having to make the investment. So just let the viewers out there know that we do offer a try before you buy on certain models of camera, which basically means that you can borrow this camera for a week or a period of time, basically, and see how you get on in your day-to-day work. And then that investment is then offset against the cost of a new camera, just so that you can be sure that you're getting the right equipment for the job in hand.
Yeah, no, I mean, and obviously more traditional hire services as well.
Yeah, absolutely. So obviously I'd said that was for the higher end cameras.
Yeah.
Well, not necessarily higher end cameras, really case by case scenario. But the lower end cameras, we do offer a higher fleet as well and a higher service. So even if you wanted to try one of the E5 pistol grip cameras, we can hire those for either a 3 or a 7 day period, just to give you an idea of what they're like. Yeah, so I think what we can really conclude here is that this technology is available to the masses these days. There are solutions available from around about the £200 price on the market. So there really isn't a better time to invest. And, we'd be more than happy to help out with any inquiries. So please do get in contact with us.
Thank you, Jason and Chris, for joining us today.
It's been good. Thank you.
If you'd like more information on thermal imaging or how it can benefit you, please visit the website or get in touch and we'll be more than happy to help. Thanks again to our guests, and I hope you can join us again in our next episode.